Hello students, we will now take a look at what is known as a resistance box. We normally use it for various experiments. I will just show you the construction and I will also let you know a few questions on that as well. These keys here, when removed, and there are these numbers here which are shown here 10, 20, 20, 50, 1, 2, 2, 5, so on. These are the resistance values in ohms. This one is 50 ohms, 20 ohms, 20 ohms, 10 ohms, 5 ohms, 2 ohms, 2 ohms, 1 ohms, right? And this one is an infinite resistance. Now, when you have to introduce a certain value or a trial error value of any resistance, when you remove this one, that means that you are introducing 20 ohms in the circuit. When you plug it back, there is no resistance values at all. If you remove this one, you are introducing a 50 ohm resistance and you place it back. And if you for some reason remove this, you will be removing a infinite resistance. You can take out a combination of all these. They are all in series. Therefore, whatever number you remove, for example, if you remove this 10 and 20, it becomes 30 ohms. Fine. So this is 10. This is 20, that becomes 30 ohms. If you remove this 50 and 20, it becomes 70 ohms. Place them back. If you remove this 1, if you remove this 50, it becomes 51, so on, so forth. Let me take just one last example. You take this 2, you take this 10, it becomes 12 ohms, right? Now, you have to remember that you will have to keep these keys as tightly pressed in as possible. That's because here, to introduce a resistance value, we remove the key. So if you leave a key loose, then what will happen is that much amount of resistance will get added into the circuit. For example, you are doing an experiment with 10 ohms and you left this key 50 ohms loose. Then what will happen? You will actually be working with 10 ohms, but in the circuit, it will actually be working to 60 ohms. So your results will not match. So you will have to ensure that these keys are as tightly keyed in as possible. Now, one thing that should come in your mind is, this is a plug key which normally is used to start or stop a circuit. So when you remove the plug key, what happens? The current gets stopped and the circuit is broken. But when you plug the key in back, the current starts flowing again. See the difference, huh? Here I key in the plug key, the current starts, but here if I plug out, then also the current does not stop. Can you tell me why? This is whatever value, anything I remove. So here if I remove this key, the current stops, but here if I remove any key, that much amount gets added to the circuit. Now I will show you the construction of it. Now if you look at the inside of a resistance box, this is how it looks. Each of them will be having that much value of resistance, right? So now what happens, if you remove one value key from here, the current will pass into this and go to the next one. But if you plug in there, see this, I will show you once again. If you remove this 20 ohms or 50 ohms, then what will happen? The current from here will not stop. So from here, it will go back. It will go into this, and it will go on further. So this is what you have to keep in your mind. That is, when you remove the keys, the current will flow from within the resistance box corresponding to that value of the resistance. Whereas such an arrangement is not there in the plug key. If a plug key is removed, there is nothing at the back. So the current will stop. And now you might wonder, what is the meaning of an infinite resistance? If you see here, this is not connected to anything at all. That means it's an air gap. So air gap between any keys is as good as a infinite resistance, and this air gap plays a very unhealthy role sometimes when you are doing experiments, specifically when you do experiments on meter bridge or potentiometer. If there is an air gap, that means if you have left any connection loose, it's as good as an air gap. An air gap is as good as an infinite resistance. Therefore, the current will only flow from one end of the circuit, which corresponds to the path of the least resistance. What are the questions that can be asked in this topic? The first question is, what is the material of the wire used to construct a resistance coil? Any idea, anybody? The answer is Manganin. And why is that so? This could be a follow-up question for the first question as to why is a manganin used. Please remember that resistance always increases with temperature for metals, and resistance always increases for alloys as well with temperature. So now as the temperature increases, you do not want the resistance of that material used for the resistance to change its resistance because of the increase in temperature. So we require a material which has got a very low temperature coefficient of resistance, and that property is found in this alloy known as the manganin. The value of this is 0.000002, that is 2 into 10 raised to minus 6 per degree centigrade. It is that low, and it is one of the reasons why it is preferred as a resistance coil material. Next question could be, define resistance. It can simply be told that resistance is the property of a body to oppose the flow of current through it. The next question that could come across would be, how does the resistance of a metal behave with temperature? Now you should always say that the resistance of metal increases with increasing temperature, and if they ask write the relationship or write the relation how it behaves, then RT is equal to R0 into 1 plus alpha T. They may ask you what do these symbols RT or R0 or alpha stand for. You can respectively say RT stands for resistance at any temperature T, R0 is resistance at 0 degree centigrade or the original resistance, and alpha is the temperature coefficient of resistance. They may even ask you to define the temperature coefficient of resistance, which may be defined as the increase in resistance per unit original resistance at 0 degree centigrade per degree rise in temperature. There could be some more questions as well. Are the resistances in a resistance box connected in series or parallel? The answer is they all are in series. That's why when you remove the plugs from individual ohm value, they all get added up. Can you state the law of resistances in series? Your statement should be, the law of resistances in series states that when a number of resistances are connected in series, then the effective resistance is equal to one single resistance, which is a sum of all the individual resistances. They could even ask you if you would be able to state the law of resistances in parallel. So what should your answer be? The law of resistances in parallel states that the reciprocal of the effective resistance is equal to sum of the reciprocals of the individual resistances. Now they may combine these two questions and ask you, will you be able to write an expression for the law of resistance in series or the law of resistance in parallel? Then you should be able to write, for series, R is equal to R1 plus R2 up to Rn, and for parallel it will be 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus up to 1 upon R.